to find when f of x is greater than g of x, given a chart that represents two continuous lines for all real numbers, the first thing we have to do is we have to see when f of x equals g of x. F of x equals g of x when they have the same value in the chart. So that would be at x equals negative 1. Then we need to look past that and see on which interval, either this direction or this direction, are the values of f of x more than the values of g of x. So if we look this direction, f of x is 0 and g of x is 1. That's not more than, f of x is not more than g of x. 0 is not more than 1. But if we look in the other direction, f of x is 6 and g of x is 5. Then f of x is 9 and g of x is 7. The value of f of x is always more than the value of g of x for all the numbers after negative 1. So we will say that this is true when x is greater than negative 1. Or in interval notation, we'll start at negative 1 and go towards infinity. The negative 1 stays in a parenthesis because it's just a greater than, not a greater than or equal to sign. If we change the inequality sign up, the process is still the same. We first have to look for when f of x equals g of x, when they both have the same value in the chart, happens to be at negative 1 again. Now this time we want the values of f of x to be less than the value of g of x. So if I look up here, 0 is less than 1. But over here, 4 is greater than 3, 6 is greater than 4. We want f of x to be less than g of x, so we want to go in this direction. That would be the numbers that are less than negative 1. So we'll say that x is less than or equal to negative 1 because we have the or equal to over here in our inequality. If we were to write that in interval notation, remember that less than negative 1 means we're going towards negative infinity. And then we get cut off when we hit negative 1 with a bracket because of the or equal to on the inequality sign. Here we have f of x is less than g of x. So again, we'll just figure out where they equal each other. That would be at x equals 2. And now we want the values of f of x to be less than the values of g of x. Be careful not to pick this one, even though 17 is less than 18. Negative 17 is actually greater than negative 18. Right? But negative 9 is less than negative 8. Negative 5 is less than negative 3. Negative 1 is certainly less than 2, and 3 is less than 7. So we want to go in this direction towards negative infinity. We want x to be less than 2, 2 being the place where they equaled each other. If we go from 2 backwards towards negative infinity, our interval notation should look like negative infinity to 2 with a parenthesis because it's just a less than sign. And our last one here, f of x is greater than or equal to g of x. They equal each other when x is 1. And we want f to be more than g. So 5 is more than 2, 7 is more than 1, but 1 is less than 4, negative 1 is less than 5, negative 3 is less than 6. We don't want this section. We want this section. We want the numbers where we are greater than 1. And in fact, we'll actually be greater than or equal to 1 because our original inequality says f of x is greater than or equal to g of x. And if we are talking about this in interval notation, we start at 1 and go to the numbers that are greater than 1, which approaches infinity. We have the bracket on the 1 because it's an or equal to, and the parenthesis on the infinity.